Hello viewer, a warm welcome to Elimu TV where you continuously watch and learn. Our today's subtopic is going to be features resulting from faulting. I am your Madam Abigail Rachel, and we will continue to look at the internal landform features as well as the external landform features. But for our major right now is the internal landform features that result from faulting. And so in the last lesson, we looked at the type of faults, and we said that faults originate from forces that could either be compressional or tensional forces. And these are the forces that are applied to the Earth's crustal rocks that are beneath the surface of the Earth. So naming the types of faults, there is the strike-slip fault, there is the normal fault, there is the thrust fault. Other faults include the reverse fault. We also have the thrust fault. So that was just what we looked at in our last lesson. And we also looked at the parts of a fault. So in the parts of a fault, we have the stress, we have the footwall, we have the fault scarp, we have the fault line, we also have the hanging wall. For my question today that I'll give a present, I'm asking you to give me a short definition of what these parts of a fault are. If it's a fault wall, tell me what is a fault wall. If it's a hanging wall, tell me what is a hanging wall. If it is a fault scarp, SMS me a short description of what a fault scarp is. That is in 160 characters. I'll give you a present when you SMS me on that. And continuing with today's lesson, we are looking about the features resulting from faulting. And so in the previous lesson, we looked at faulting processes. And out of the faulting processes, we got the types of fault, the normal fault, the thrust fault. But today we are going to look at features resulting as a result of this faulting that has taken place. And one is a fault scarp. A fault scarp is also known as an escarpment, and this results when a fault displaces the ground surface. So when we have the forces acting on the Earth's ground surface, we will see that one surface will be displaced by another one. And so this will lead to the formation of an escarpment. And it can also occur when there is a steep slope formed by the vertical displacement of a land along a fault. So a fault is normally in somehow like a right-angled triangle where you have one side of the land that is slopey and is steep, and it has been displaced vertically by another fault. To continue on fault scarps, so fault scarps normally exist on the walls of the Rift Valley and over the seas where we have parallel scarps. And some of these parallel scarps that you have include the Grumman, the Elgeyo, the Mau, and the Nyandarua. So these are Rift Valley mountains that we have in Kenya. And moving ahead, where we have the image of a fault scarp. So on an image of a fault scarp is over here on this image below, where you have a fault scarp being labeled, where you have the fault scarp being labeled on this image that you have. So when you look at the farthest part where we have the trees, this is the upthrown block, and this is the block that has been lifted above the other block by compression or either by tensional forces. We also have the footwall, we have the fault plane, we have the hanging wall, and in our last lesson we looked at a hanging wall. This is another question that I have for you. You can give me feedback on 2518 for present. And we have the fault line and the fault scarp. So in defining the fault scarp again, this is the vertical This is the vertical line or the vertical steep slope that has been set as a result of fault or blocks moving past each other. And we have seen that they are mainly found along Rift Valley walls, including the Nyandarua, you have the Mau, you have the Elgeyo, and you have the Guruman. Another feature resulting from faulting is the fault step. So a fault step is formed when you have a series of fairly parallel faults that occur on a slope area. From the word step, where we walk with our one leg moving at a distance from the other leg. So in our fault steps, it is just they borrow from each other, from the way our movements of the legs work with each other. So for the fault steps, we normally find that, or in the images, we can move from one fault block to another in a step way of form. And these blocks, they are found between the faults, are displaced vertically to different levels. So they either rise or they are either lower from one different fault. And they mainly, the blocks in between them, they are vertically displaced so that they can form something that you can say it is a step. You move from one place, you move from one fault block to another fault block. Here is an image of a fault steps. So when you look at this image properly, the first image where we have an arrow pointing downward, you see that this is the first fault step. This is the first fault block. Then either to the right or to the left, it is another fault step. Going to the right again, we have another fault step. Looking on the second image, where we have the arrow pointing upwards, this is a fault. It is a fault block. Then moving to the right and moving to the left, it's another step and another step down there. So fault steps, they can be many, or it can be one, or it can be even just many of them. Another image is the HORST or fault block. You have heard of HORST mountains or even fault mountains. So for our HORST block, our HORST block is formed when we have a block of land being bounded by faults on either sides and which they stand above the surrounding area. So here we have a land surface that has undergone tensional forces. And we looked at tensional forces. They pull the earth's surface rocks away from each other. So as these forces act on these rocks, we will have part of the land sinking and part of another piece of land that is going to be uplifted. So the type of land, the land that is going to be uplifted, we will say that this is our HORST block. And they are HORST blocks mainly form as a result of tensional forces or compressional forces. Here is an image of a HORST block in form of tensional forces. So as the tensional force act on the land surface, they tend to pull or to stretch the land away from each other. So part of the land is going to sink and the other part of the land is going to be uplifted. So the HORST block is this part of land that is going to be uplifted to be higher than the other part that is going to sink. HORST block may also occur as a result of compression forces. And in compression forces, we have this land, we have these forces pulling land or pulling these earth surface rocks towards each other. So when you have the rocks being pulled towards each other, you have some part that is going to still sink, with another part is going to rise up above the land surface. So for compressional forces, the land that still rises up from the other surface is still going to be called the host block. So for our image here, we have the block mountain, and this block mountain has been formed due to compression forces. And the compressional forces has forced the plates to diverge from each other. And this is an image of the Graben Rift Valley. And we have the block mountains being formed as a result of compression forces. Looking at another image, so in this image, you can see the features resulting from faulting, and one is the fault scarp. Another thing that you can see is the host block, and this host block, this is the land that is either uplifted, or this is the land that is going to sink as a result of the compression forces. We have come to the end of our lesson today, and here's an assignment for you. Name the types of features resulting from faulting. So list some of the features resulting from faulting. Give us feedback on SMS, that is 2518, Facebook at Elimu TV, and Twitter, that is at Elimu_KE. Thank you.